And TESTAR tool has a very modular architecture that fosters research around it. TESTAR is originally an academic tool, which means that it was built for research. So the TESTAR core, it's built in Java language, and it's basically has certain directions of extension that can be easily done. First of is a kind of a plugin architecture for test oracles. There are several test oracles already implemented in the tool, and some of them are still under development. There are generic oracles, which include, for example, noticing when the system under testing is closed, or for example, if it becomes unresponsive. Then there are what we call suspicious titles, which is a way of defining some sort of titles that are, if they are found in any part of the UI, they are called suspicious, and then those are marked as possible errors. You can use regular expression to define these titles, and they are constantly looked for in the UI during the test execution. Then there are external oracles. This means that you can also define oracles that are looked for after test execution. And one way to do that is that using a graph database, which is basically collecting a state model of the observed behavior of the UI, and afterwards you can make queries to find some specific behavior that you think that is not correct. Then there is ongoing research going for mining possible temporal oracles specified in LTL, and this is basically a similar thing than the external oracles that you could do during the execution, but mainly afterwards from the graph database. Another direction of extensions is plugins for action selection algorithms, and there are several of them already implemented. The most basic is random, and that's the default behavior of TESTAR if you don't choose something else. But there's also one implemented for Q-learning, which basically uses a reward function to try to select actions that have not been selected before, and over time it's finding new actions to execute. There have also been some research related to genetic algorithms trying to evolve the best possible action selection algorithms. And this direction is also still being researched, and there are new master studies done towards this direction. Then there's another topic for research which is still ongoing, and that's using model extraction for the action selection. And this way you can learn the model, and while still exploring the UI, you can use the existing model for guiding the action selection into specific directions. And this is very good way to explore every part of the UI during the exploration. Third direction for TESTAR extensions is platform or API support. As TESTAR is using by default, it is using Windows UI automation API to access to the what is actually visible on the user interface, and also for the interaction bit for the system under testing. But the problem is that all applications are not based on Windows. There is also implementation for that is using WebDriver, and that works quite well for the web-based applications. Then there is research ongoing for Android, basically using Android tools for interactions, and also detecting what are the widgets available on the UI. There has been some implementation for Linux as well. That might not be up to date, but there has been some implementation in that direction as well. And originally, TESTAR was developed for OS X or Mac OS, but I think that has been that is maybe not working with the latest versions anymore. There was also one research trying out REST API for Internet of Things system, and that is an example that TESTAR could be used also for other than graphical user interface applications. And that was all.